Welcome to the Blockchain Philosopher channel, where we explore blockchain solutions to everyday problems. Today, we are going to provide a simplified explanation of the concept of immutability, a core component of the blockchain and cryptocurrencies. Immutable simply means that something cannot be changed. Once it has been created, it is fixed and permanent for all time. Think of it like a message carved into a solid stone tablet. The letters are etched deep into the rock itself, becoming a part of its very structure. You cannot easily wipe them away or write something new over the top. That original message is set, a permanent record for anyone to see in the future. This idea of a stone tablet helps explain a powerful feature of blockchain technology. The concept is not about complexity, it is about creating a lasting, unalterable truth that can be relied upon. This permanence is different from how we usually handle digital information. Most digital files, like a document on your computer or a photo on your phone, are very easy to change. You can open a file, delete a sentence, add a new paragraph, or even replace the entire thing. The digital world is typically fluid and changeable. Blockchain, however, was designed to work differently. It brings the permanence of a stone tablet into the digital realm. The power lies in the trust it creates. A blockchain works like a special kind of digital notebook, where each page is called a block. Each block is filled with records, such as a list of transactions and other data. Once a block is full, it is sealed and added to the end of a growing chain. This is not like a regular notebook where you can tear out a page or erase what you wrote. Each new block is permanently linked to the one before it, creating an unbroken history. Before a new block can be added, a complex mathematical puzzle must be solved. Many computers race to solve it. The first to find the solution adds the block and earns a reward. This process is called mining. Because so many independent computers validate information, no one can easily slip in a fraudulent block. It is collective agreement, like thousands of notaries reviewing the same document at once. When they agree, it is stamped into the record, and everyone moves on to the next page. This distributed consensus makes cheating incredibly difficult. You would have to fool thousands of observers simultaneously, which is practically impossible. Adding a new block is like hiring a master stonemason. Only after a huge crowd of inspectors approves the message can the carving begin. Then the new information is permanently added, verified by all, into the growing record. The connection between the blocks is what truly makes the blockchain immutable. It is not just a list of records, it is an interlocking chain. Each block contains its data and a unique digital fingerprint, called a hash, from the block before it. A hash function is a digital blender. You throw in any data and get a unique digital fingerprint out. Take the expression blockchain philosopher. Convert it to a 64-character hexadecimal. Now change the expression slightly to blockchain philosopher with an added exclamation point. The new output is an entirely different hash. This hash acts as a secure seal, linking each new block to its predecessor. This creates a dependency that connects every block to the last, all the way back to the first one. That chain of hashes makes history extremely difficult to alter. Imagine each tablet has a piece of the previous tablet's pattern carved into it. If you change one in the middle, you cannot just alter that single one. Because its pattern is etched into the next tablet, you would have to change that one too, then the next, and the next. Altering one creates a ripple that breaks the chain and exposes the change immediately. An attacker cannot just edit an old block because it would change that block's hash. The next block would no longer match, breaking the link. The network instantly sees the discrepancy and rejects it. To succeed, they would need to recompute every subsequent block, an enormous, unrealistic amount of power. It is like recarving an entire mountain of tablets faster than all the honest stonemasons adding new ones. This immense difficulty is the core of blockchain security, and why its records are effectively immutable. However, immutable does not mean infallible. If wrong data is entered, garbage in, garbage out, that mistake becomes permanent history. You cannot edit the old entry. You create a new transaction to correct it, and both remain visible. On large public chains like Bitcoin and Ethereum, the vast participation makes records practically unchangeable. On smaller private chains, administrators may reverse transactions by rule, tamper-resistant, not absolute. By linking blocks with cryptographic hashes and distributing the ledger, blockchain makes records hard to change, like words in stone. That yields new trust and transparency for digital information. We must still mind the permanence of errors and varying private rules, but immutable records help secure data and build trust. Thank you for watching. Stay tuned for more videos outlining blockchain solutions to everyday problems.